Intersection of solids. Here we have the 2004 question on interpenetration. So let's have a look at the question. Figure 3 shows the projections of a solid composed of a square base pyramid standing on a square base prism. The solid has been cut as shown. Also shown are the incomplete projection of the equilateral triangular prism of 60mm side, which penetrates the solid. Draw the projections of the solid showing all lines of interpenetration. So we begin by drawing the square base pyramid on the square base prism, and we also draw a 60mm line, which is a true edge length triangular base prism, like so. Now we must find the true surface of the triangular base prism, which intersects the square base pyramid and the square base prism. This is achieved by striking an arc from each end of 60mm. This will locate the apex of the true surface of the triangular base prism. Now we draw in heavy. From this we draw an x1, y1 line, like so, which is perpendicular to the prism projection lines. We then bring down these lines through and find our height from plan, like so. Now we can locate the prism in plan, as shown. Now we must draw a solid in an auxiliary, like so. This is achieved by bringing all points from elevation down to this auxiliary view. We can then add in hidden detail, as this is very important because the prism intersects the solid both from the left and the right hand side. Now to find the piercing points, which is key to locate the lines of intersection. Label 1, 2 and 3. This will make life a lot easier. Now we locate where these points intersect the solid. After locating the points A, B and C in both elevation and plan, we must then locate more points in the auxiliary view. This is achieved by the red lines. The red lines are used to find points in the elevation which can be dropped to locate them in the plan, like so. E is found. We project E from this corner till it hits point 1, till it hits the intersection of the square base prism and the square base pyramid. We then project this line up till it meets the same line in elevation. We then project this line back up to where it is to be found at the top of the elevation. Where this red line intersects the construction lines from earlier, which show the true cutting surface of the triangular base prism, we drop this point until it's found in plan on the same surface in elevation, like so. Now, after locating A, B, C, now we have D, E and F as shown. Now we can project and find more points where this edge intersects the triangular face of the prism. We project this line back up until it hits the surface or edge in elevation and drop to on plan, like so. We do the same with the hidden detail lines as seen here and here. We project them up. This gives us H and I. We drop these down until they meet the same edge in plan. Now we also have H, I, and J and G in plan as well as elevation. Now we get 2 more points where the triangular base prism intersects both the top surface in auxiliary and the bottom surface in auxiliary, and these are projected up till they meet the same surface in elevation and drop to plan, as you can see, L and K. Now that we have these points, we can join them up. It is difficult to find which points are going to be hidden and which points are going to be seen. Focus on the plan. This will show us in elevation which points will be seen and which points will be in hidden detail. As shown in plan, D, K, G will all be seen in the elevation, but L, E, G will be hidden. Likewise at the other end of the surface, J, G are hidden, M, I can be seen as well as A. The same in the other end. We can see that M, A can be seen in plan, so therefore it will be seen in elevation. I will also be seen, like so, and this helps to locate the hidden detail within elevation. Now we take away the lines. Now we can see where the triangular base prism intersects the square base pyramid and the square base prism, like so. There is your answer.